All right, welcome back to pre-calculus final exam prep here. So we have an ellipse here, right? Consider the equation of the ellipse below. Here we go. And then the first thing we got to do is put it in standard form. We got to figure out the center, got to figure out the endpoints of the major and minor axis, get the foci, and then make a sketch here. All right. So the first thing I'm going to do is I'm going to go ahead and write this thing down. So we have here's a 3x squared plus 10y squared plus 12x minus 120y plus 342 is equal to 0. All right. Now, what we want to do here is we want to do something called complete the square. All right. Now, we're going to go ahead and group all the pieces together. So this was plus 12x. Leave some room. 10y squared minus 120y, and we're going to say equals negative 342. Right? Now, there's a lot of different ways to complete the square. If you watch any other YouTube video on how to do this, you'll probably get a slightly different version of it. They're really all the same. You can do this however, whatever method speaks to you. I want you to do it that way. You don't have to do it my way specifically. Okay. So we have 3. We had x squared plus 4x, right? Again, I'm going to leave that room there, plus, and then here we have 10y. So actually, we're going to go ahead and factor out that 10 from the y's here. So we have 10, and then we have y squared minus 12. Leave some room, is equal to negative 342. Okay. Now, on the x side of this thing, okay, the reason I factored it out, first off, is because complete the square only works when the coefficient here is a 1. Okay, so we force the issue and pull everything that's not a 1 away from it to force us to be a 1. Okay, now this middle term here, right, this is the x part, so I call it bx because quadratic formula, right, it's ax squared plus bx plus c, so it's b. Okay, that equals 4. And then we're going to divide this by 2, so we get 2. Okay, remember this 2, it's going to be important later. Bx over 2 squared, that is equal to 4. So we're going to add 4 and then subtract 4. So we just added 0. All right, that's okay. Okay, for the y side, right, by, right, the middle term for y, what is that? Negative 12, right? And then if we cut that in half, right, we get negative 6. And again, that's going to be important later. And then y over 2, and we're going to square it, and that is negative 6 squared is 36. So we're going to add 36 and then subtract it. Okay? Again, we added 0. We added nothing. But again, I'm going to go ahead and group them like this. Okay? Well, it turns out that x squared plus 4x plus 4, this is a perfect square, okay, by itself in here. And what square is that? So that's going to be 3. Actually, I'm going to go ahead and do the brackets here. Okay, so it's going to be 3. We have x plus 2 squared, okay, minus 4, because we still didn't, we still have this. I just didn't know what to do with it just yet. Okay, plus 10. And then here, we're going to complete the square. X squared minus 12y plus 36. This is the complete square. And that is y minus 6 squared. And we have minus 36 here. Okay, so wait a minute. You minused, how come you have 2 minuses? When I FOIL this out, it would be a positive 36. So we still have the negative 36 here. This is how it's always going to factor. You see this negative 6 here? Notice that's a negative 6. Always going to work that way. It's 2 here, it's 2 here, it's always going to work that way. So if you follow this method and do the b over 2, and then square it, that b over 2 thing, that's always going to be what you're factoring to. So no matter how crazy the numbers get here, you have some horrible fractions, some horrible irrational numbers, you can always reconstruct it and go back to this, and you can factor it. So no matter how crazy it looks, You still got this. Right? Not going to do anything with that. Now what I'm going to do is I'm going to go ahead and distribute. Okay. So the 3's got to visit the first one. That's 3x plus 2 squared minus 3 times 4 is 12 plus 10 y minus 6 squared minus 360 is equal to negative 342. All right. Now, I said put it in standard form. What's standard form for an ellipse? That's x minus h squared over a squared plus y minus k for the vertical over b squared is equal to 1. I always put the a under the x and put the b under the y. Your book talks about major and minor axes, so if they're bigger, like they swap them. Like, okay, that's fine. Okay, but I'm not that concerned about having the spelling right. Okay, so we're almost done here. We have 3x plus 2 squared plus 10 y minus 6 squared, and that is equal to, right, negative 342 plus 360 plus 12. All right, and what's that going to give us? I think it gives us 30, but I don't know. A negative 342 plus 12 plus 360. It gives us 30. Go figure. We have 3x plus 2 squared plus 10 y minus 6 squared is equal to 30. So you notice my standard form. How many things are in front here? None. Okay, they're all in fractions. What's on the right-hand side? 1. So we're going to go and make that a 1. All right. So we divide everybody by 30. It's 3 over 30. That's 10, right? Plus 10 over 30. What's that? That's 3. That equals 1. So my b squared, right, is equal to 3. My a squared is equal to 10. Okay, so that's how we're going to take care of that. All right, but there's my form. Okay. Now they're just going to ask us a bunch of questions about this thing. Okay, I don't think I asked quite so many questions on the final. I think I kind of, because it's already kind of a long problem. So I think I just asked a few. If there's a foci on there, I think I included that in your formula. I think I included standard form in your formula list too, so you'll know what it's supposed to look like. Okay. There's the equation in standard form. B, what's the center? Well, remember how we did circles, right? Our center is negative 2, 6. Okay, it's the center of the ellipse. How do I get that? Well, it's x minus whatever comes next. X minus negative 2. Y minus 6. Negative 2, 6. What are the endpoints of the major axis? Now, remember, it's from the center. Okay, so the value we're going to get is from the center. So what we're going to do is we're going to set x equal to negative 2. What's that going to do for this? That's going to be 0, isn't it? Plus y minus 6 squared over 3 is equal to 1. So we get y minus 6 squared equals 3, right? So square root of both sides, y minus 6 is equal to plus or minus square root of 3. So y is equal to 6 plus or minus root 3. What about the other one? Okay, we're going to set y equal to 6. So we have x plus 2 squared over 10 is equal to 1. X plus 2 squared is equal to 10. We're going to take the square root of both sides. So we have x plus 2, parentheses, plus 2 is equal to plus or minus the square root of 10. So x is equal to negative 2 plus or minus root 10. Okay? Which one's bigger, root 3 or root 10? Root 10's bigger. So this is my major. This is my minor. Okay, the major is just the bigger one. The minor is the smaller one. Okay. So let's get the points. So we have x equals, right, -2 minus root 10. What was y? Y was 6. And -2 plus root 10. And then 6. Okay. How about the minor axis? Okay, so it's going to be, right, what's x? X is -2. And then we have 6 minus root 3. All right. And then we have -2. And then 6 plus root 3. Okay. These are the endpoints for the minor. This is the endpoints for the major. Okay. So that's not so bad. So the endpoints of the major, endpoints of the minor. What are the foci? Okay. So remember, c squared is equal to a squared minus b squared. Bigger one, smaller one. Okay. Don't, if they, your a happen to be the smaller one, just swap them. Okay. So we have c squared is equal. Okay. What's a squared? A squared is 10. Right? Don't you have to square something? No. A squared is 10. That's our form. Minus b squared. That was 3. Okay. So c squared is equal to 7. C is equal to plus or minus root 7. And again, this is from the center. Okay, your foci are plus or minus root 7 from the center. All right, and it's along the major axis. Okay, so it's from the center along the major axis. The major axis was along the x side. Okay, so we're going to get -2. Oops. -2 minus root 7. I wish some of the other programs, you just circle it and erase that circle. I don't know how to do it from this. Okay, what was y? Y was 6, right? And then we have -2 plus root 7. Okay, 6. These are my foci. Okay. Next, and by the way, I don't expect you guys to memorize foci. If I ask you a question about it, it's going to be on the last question on the final. Okay, last question is a true or false final, a true or false question. It's got a bunch of formulas listed on there after that. The answer is true. Okay. It's not even worth a point. It's worth almost nothing. So, don't get it wrong. But if you do, it's worth a penny, okay, of a point. So it's not a big deal. You don't have to memorize this. Yeah, I've never been asked the eccentricity in my entire life, and that was even including when I worked on satellites. So yeah, we're not doing that. Okay, what's the center again? Center was -2, 6. So that's second quadrant, isn't it? So all the action is going on second quadrant. So here we go. We have 1, 2, 1, 2, 3, 4, 5, 6. Here's my center. Okay, where are my endpoints? My endpoints were -2 plus root 10. That's close to 3. It's a little bit more than 3, actually. So 1, 2, 3, 4. So here we are. 1, 2, 3, 4. So here we are. Okay, pretend that's symmetric. Okay. The minor endpoints were 6 minus root 3 and 6 plus root 3. So root 3 is like almost 2. So 6 minus 2 is about 4-ish. And 6 plus root 3 is there we are. All right, so I'm going to say pretend this looks like an ellipse. All right, and there you are, you're set. Okay. So you don't have to map the foci out. There's nothing else that you really have to do. So there you go, you're set. All right. So I think we're going to do the hyperbola next time. So that one's a little bit harder, especially if it's not centered. And the one on the preview isn't on the origin. I think the one on the final is. So I was looking at it, I was like, wow, that's a long problem. So I tried to make it a little bit smaller. So ellipse net or hyperbola next, and then we'll go from there. Okay. So I'll see you in a little bit. Oops, I don't want to do that. I want to quit.